Once we know how to simplify rational expressions, we can then engage with operations on rational expressions. In this video, we'll focus on multiplying and dividing rational expressions. Let's start with multiplication. Here's the procedure. If P over Q and R over S represent rational expressions, that is, they're the quotient of two polynomials, then P over Q times R over S equals PR over QS. This rule is simply indicating that we follow the ordinary rules of multiplying fractions and multiply straight across the numerators and straight across the denominators. However, sometimes that creates a very cumbersome, complicated rational expression. So we're going to attempt to reduce before we multiply. So number one, the first thing we want to think about is factoring each numerator and each denominator completely using various rules. That is, factoring out the GCF, factoring by grouping, using a special factoring formula, or even just a basic trinomial. Once we have everything factored completely, then we can divide out common factors. And finally, number three, we'll actually multiply the remaining factors in the numerators and denominators. If we have canceled appropriately in advance, our result should already be in simplified form. Let's give this a try on example 2. So we've got the product of two rational expressions. So the first thing I want to do is factor my first numerator. I notice there's a greatest common factor there of 5. So I'm going to take out 5 as the GCF, divide the remaining terms by 5, and that leaves behind the binomial factor x minus 1. For my first denominator here, we have a greatest common factor of 2. When we take that out, it leaves behind the binomial x plus 2. Next, we'll work on our second numerator. Well, it's completely reduced. There's no GCF I can extract there. I am going to put a set of parentheses around it. And then in the denominator, notice we have the difference of two squares. So we could factor that one as x plus 1 times x minus 1. So everything has been completely factored. Now we're going to look for common factors. We can cancel out the x minus 1 and the x minus 1, and we have a pair of x plus 2 factors that we can cancel as well. The only thing that remains in the numerator is a 5, and in the denominator we have 2 times the factor x plus 1. Now, it's perfectly acceptable. In fact, it's preferable to leave everything in factored form. So there's no need to distribute that 2 to the factor in the denominator. Okay, let's try example B. Remember, our first step is to completely factor every numerator and every denominator. So let's look at our first numerator. Notice we have a greatest common factor here of y. So we'll take out a y. That leaves behind 2y minus 3. Now, for our first denominator, we have a trinomial whose leading coefficient is not 1. So we will factor this with the trial and error method, anticipating two binomial factors. Now, because that first term has a prime coefficient, there's only two possible factors of 2, and that's 1 and 2. So I'm going to have a 2y in the first factor and a y in the second factor. Now, looking ahead a little bit, because this sign is negative, we can anticipate two different signs in our binomial factors. Remember, DSD helps me to remember different signs difference. So one factor will be positive, one factor will be negative. And my middle term will be the difference of the outside and inside terms. This one tells me that the biggest product must be positive, the biggest product between my outside and inside terms. Okay, let's take a look now at our last term. The factors of 6 are 1 and 6 and 2 and 3. So we're going to choose an appropriate pair. So again, thinking ahead a little bit, how my outside and inside terms are working together, I'm going to use 3 in the first factor and 2 in the second one. Notice my inside terms here have a product of 3y, and my outside terms have a product of 4y. That's going to give me a difference of 1y, but I need to make sure that it turns out to be a positive 1y. So I want my biggest product to be positive. The biggest product is the outside product, and the smallest product is the inside product. Okay, so just to be clear, notice the inside terms have a product of negative 3y. Outside terms have a product of 3y. If I add those together, that gives me the correct middle term. Okay, that one was hard work. Let's look at our next numerator. The next numerator, that one's a piece of cake, right? That's the difference of two squares. So we factor it y plus 2, y minus 2. Again, the 2 is the square root of that number. And then we have this cute little monomial term hanging out in our second denominator. That one does not need factorization. Okay, let's see if we have any common factors. So we can mark out 2y minus 3. We've got a pair of y plus 2's that match. And then notice I've got a y in the numerator and a y squared in the denominator. So I can cancel out one of those y's. That's going to leave behind y to the first power in the denominator. So we end up with y minus 2 over y. And that one is completely reduced. Okay, if we know how to multiply rational expressions, then we're just going to add one extra step in order to divide rational expressions. And remember the pattern of dividing fractions. If p over q and r over s are rational expressions, then p over q divided by r over s, remember we're going to change our operation division into multiplication, and then we're going to invert that second fraction. Once we do that, we can follow the ordinary rules of multiplication, which say multiply straight across numerators and straight across denominators. So this feels just like dividing numerical fractions, except we're dealing with polynomials. So to apply this to rational expressions, number one, we're going to change division and multiplication and invert the divisor, or the second fraction there. And then we're going to follow the procedure for multiplying rational expressions that we just practiced. Okay, let's give this a try on example 3. Divide and simplify. So the first thing I want to do is get out of division into multiplication. So I'm not going to make any changes to the first fraction. I'm going to change my operation from division to multiplication, and I'm going to invert that second fraction. So I'll have 3x plus 6 on the top and 4x plus 8 on the bottom. Our next goal is to factor each numerator and denominator completely. Well, the first fraction is already reduced as far as possible. My second numerator here, we have a greatest common factor of 3. So if we take that out, that leaves behind an x plus 2. In the denominator, we have a greatest common factor of 4. So we can take that out, and that leaves behind an x plus 2. So clearly, we can divide out the x plus 2's, and then notice we have a 3 in the denominator here, a 3 in the numerator here, and there's one more common factor, and that's 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So this big problem reduces all the way down to x over 2. That looks much better than what we started with. So we have a big problem for our last one in this video. We have x cubed minus 8, the difference of two cubes, over x squared minus 4, difference of two squares. And we're dividing by the quotient of two trinomials, each with a leading coefficient of 1. So we're going to do a lot of steps on the first round here. Okay, first thing I'm going to do is just copy down my first fraction. X cubed minus 8 over x squared minus 4. Then I'm going to change my division into multiplication, and then we're going to flip over this second fraction. So the change here, we have x squared plus 5x plus 6 as the numerator, x squared plus 2x plus 4 as the denominator. Then we need to work on factoring everything. I'm going to scoot over here a little bit so I can make sure and have enough room. So the first thing we want to factor here is x cubed minus 8, which is the difference of two cubes. So remember, we're going to have a binomial times a trinomial. My binomial first term is going to be the cube root of my first term, the cube root of x cubed. The second term here is the cube root of 8, which is 2. And remember, our sign here is going to match this sign here. So we're going to have a minus right there. Okay, to generate the terms of our trinomial, remember we square the first term to get x squared. We have the opposite sign here. We multiply the first and the last to get this term, already having determined the sign. This one's always positive, and then we're going to square that one to get 4. Okay, so there's the factorization of the difference of 2 cubes. In the denominator here, we have the difference of 2 squares. So that factors as x plus 2 times x minus 2, the product of 2 conjugates. Working on our trinomials, they're each going to break down into 2 binomial factors. And the good news about both of these is they have a leading coefficient of 1. So I know in the first 2 spots, we're going to have an x and an x. This one tells me that the signs of my binomial factors are going to be the same sign sum. This one tells me they're both positive. So we know we're going to have a plus and a plus. So we need to find 2 factors of 6 with a sum of 5. The factors of 6 are 1 and 6 and 2 and 3. The pair with a sum of 5 would be 2 and 3. Okay, let's work on our last trinomial in that denominator. We're anticipating it breaking down into 2 binomial factors. Because our leading coefficient is 1, we know the first position in each binomial factor is just an x. Okay, let's think about signs. Again, this has the same sign pattern as the trinomial in the numerator, so we know both signs here are going to be positive. So we need 2 factors of 4 with a sum of 2. The factors in 4 include 1 and 4 and 2 and 2. The pair with the sum of 2, well, neither of those has a sum of 2. So actually, in this denominator, we have a prime trinomial. That is x squared plus 2x plus 4. That one's not factorable. Well, the good news about that is that it matches the trinomial that we got in our first numerator. This trinomial and this trinomial match, so we can mark those out. We can also reduce our x plus 2 factor, and we even have a pair of matching x minus 2's. So after all that work, we can whittle it down to the binomial x plus 3. If you need a little help with the factoring, I would refer you back to section 1.3.6, where we had the flow chart. All of the things you need to think about whenever you factor. That would be a good reference to study for this section as well.